Okay. We're rolling.
Good evening. My name is Specialist David Pippert. In this block of instruction, we will be doing task number 071-Charlie Oscar Mike-1016, convert azimuths. Before we begin, we're going to go over some administrative things right quick. The overall risk level is low. We have some hazards. We need to watch our tables and chairs and electrical cords. Just watch out for those. Don't trip over them. Okay, just watch where you're going. Maintain your situational awareness. We also have a stove in the kitchen. We want to make sure that when nobody's over there, that we leave it off, or it's when it's in use, just don't leave it unattended. In the event of a tornado, we will move the class over to room 101, and we will all take shelter in the big closet that's just down the hall and to the left. At the end of the training, we will police everything up and just make sure everything is left tidy. For environmental considerations, the Army has the green policy. We reduce, reuse, and recycle. For security, in the event of an active shooter, we will run, hide, and fight only when necessary. Now we're going to do a PCC, PCI. So everyone, please get out the following. Make sure you have your pencil, a sheet of paper, your ID card, and a water source. So go ahead and get those out and just make sure everybody has each of those. Okay, good, good, good. Okay, everybody has everything? Awesome. Again, this is task number 071-COM-1016, convert azimuths. Conditions. You are a member of a squad preparing to conduct tactical movement, and you have been directed to convert azimuths in preparation for the movement. You have been given a 1 to 50,000 military map with a declination diagram. Pencil, paper, a magnetic azimuth, and a grid azimuth. Some iterations of this test should be performed in Mop 4. Standards. Convert an azimuth into a back azimuth, a magnetic azimuth to a grid azimuth, and a grid azimuth to a magnetic azimuth without error. Note, the north-south lines designate grid north on your map. That's right here. The compass needle points to magnetic north. The grid magnetic or GM angle is the angle difference between grid north and magnetic north. Warning: when converting azimuths into back azimuths, extreme care should be exercised when adding or subtracting the 180 degrees. A simple mathematical mistake could have disastrous consequences. Step number 1, convert an azimuth into a back azimuth. Part A, add 180 degrees if the azimuth is 180 degrees or less. Part B, subtract 180 degrees if the azimuth is 180 degrees or more. Step number 2, convert a magnetic azimuth to a grid azimuth. Note, to convert a magnetic azimuth to a grid azimuth, subtract the GM angle. Warning, when converting azimuth into back azimuth, extreme care should be exercised when adding or subtracting 380 degrees. A simple mistake of 1 degree could be significant in the field. Part A, locate the GM angle, which is part of the declination diagram, at the bottom of your map. Note, the declination diagram shows both the graphic picture of the GM angle and provides a written summary of the GM angle. This written summary includes the date of the GM angle and the actual angle in both degrees and mils. Part B, determine whether the GM angle is easterly or westerly. We'll go over that in a minute. Part C, apply the mathematical formula to convert a magnetic azimuth to a grid azimuth. Number 1, add an easterly GM angle to a magnetic azimuth to obtain a grid azimuth. Number 2, subtract a westerly GM angle from a magnetic azimuth to obtain a grid azimuth. Note, as an example, given a magnetic azimuth of 190 degrees, using the above diagram, you would add 9.5 degrees to 190 degrees to obtain a grid azimuth of 199.5 degrees. Third step, convert a grid azimuth to a magnetic azimuth. Locate the GM angle, which is a part of the declination diagram at the bottom of your map. Note, the declination diagram shows both a graphic picture of the GM angle and provides a written summary of the GM angle. This written summary includes the date of the GM angle and the actual angle in both degrees and mils. Part B, apply the mathematical formula to convert a magnetic azimuth to a grid azimuth. Number 1, subtract an easterly GM angle from a grid azimuth to obtain a magnetic azimuth. Note, as an example, given a grid azimuth of 199.5 degrees, using the above diagram, you would subtract 9.5 degrees from 199.5 degrees to obtain a magnetic azimuth of 190 degrees. Okay, does anybody have any questions? Okay, what we're going to do is we're going to break this down into 3 separate performance steps. So, number 1, we're just going to take our azimuth and we're going to convert it to a back azimuth. So on your worksheet, you should have an example on your worksheet. So on part A, everyone should have an azimuth of 20 degrees. Is 20 degrees greater than or less than 180 degrees? Okay, less than. So 20 degrees is less than 180 degrees. So you'll add 180 to the 20 degrees, and you'll get a back azimuth of 200 degrees. Is everybody tracking so far? Okay, good. Moving right along. Now, if the azimuth is less, if the azimuth is more than 180 degrees, what are we going to do? We're going to subtract, right? Okay, so on your worksheet, you're given an azimuth of 270 degrees. Is 270 degrees greater than or less than 180 degrees? It's greater than. So since 270 degrees, or 270 degrees, is greater than 180 degrees, you're going to subtract 180 degrees. So subtract 180 degrees from 270 degrees, and you'll get a back azimuth of what? Very good. You'll get a back azimuth of 90 degrees. Okay? Pretty straightforward. Okay, now the second performance step. We're going to convert a magnetic azimuth to a grid azimuth. Okay? Now part A says locate the GM angle, which is part of the declination diagram at the bottom of your map. So everybody should have the map, okay? The declination diagram is located right here. So everybody find the declination diagram on the bottom of your map. Okay, point it to me so I know that you know where it's at. Okay? Good job. Okay, now we're going to convert a magnetic azimuth to a grid azimuth, subtracting the GM angle. So on your worksheet, okay, you're given an azimuth in the example of 92.3 degrees. Okay, that's your magnetic azimuth. Now look at the map. Okay, what's the GM angle on your map? 2.3 degrees, right? Stated on this map. Okay? So what are we going to do? Okay, very good. We're going to take the 92.3 degrees magnetic azimuth, and then we're going to subtract the 2.3 degrees GM angle. Okay? And that's going to give us a grid azimuth of what? 90 degrees. Very good. Very good. Okay. Next part of this step, this performance step, is determine whether the GM angle is easterly or westerly. Okay, go ahead and look at the declination diagram on the bottom of your map. Okay? Now, if the magnetic north is on the right-hand side of your grid north, that's going to be an easterly GM angle, right? It's going to be an easterly angle because it's on the right side of grid north and it's facing which direction? Okay, it's facing east, right? Okay? Now, what do you think is a westerly angle? Okay, the other side of the grid north, right? So a westerly GM angle is going to be on the left-hand side of your grid north, right? Because it's facing west. Okay? And everybody sees that. Good job. Now what we're going to do is we're going to apply a mathematical formula to convert a magnetic azimuth to a grid azimuth. So on your map, okay, go ahead and look at your declination diagram again and get your GM angle. Okay? So on your worksheet, you have 20 degrees. So we have to add an easterly GM angle to your magnetic azimuth of 20 degrees to obtain a grid azimuth. Okay, so add 2.3 to your magnetic azimuth, and what did you get? 22.3. Good. Did you get 22.3? You didn't? Okay, you didn't? All right. We'll go over that here in a minute. We'll go back over that some other time. Okay, very good. Now that's to get the easterly GM angle. Now to get a westerly GM angle, to go from magnetic to a grid azimuth, you're given the magnetic azimuth of 22.3 degrees. Okay, so we want a westerly GM angle. So what we're going to do is we're going to subtract our GM angle right here on your declination diagram, and you're going to subtract that from your magnetic azimuth. And what was our magnetic azimuth? Okay, our magnetic azimuth was 22.3, right? And so what are we going to do? Okay, good, we're going to subtract. So we'll subtract the 2.3 degrees from the 22.3 degrees, and we get a grid azimuth of what? 20 degrees, very good. Okay, is everybody trying so far? Good job. All right, so that was performance step number 2. Now the final performance step is to convert a grid azimuth to a magnetic azimuth. Again, we're locating the GM angle, which is right by your declination diagram. And I realize this is kind of a small map, but I kind of blew it up right here so everybody can see that a lot better. Otherwise, you'd have to have a pair of binoculars to be able to see this. Okay? So is everybody excited so far? Okay. Now, on any map that you read, any military map you read, is going to have this declination diagram on the bottom of it, and it's always going to have a GM angle underneath there. Okay? So that's where you're going to find your GM angle. Alright? Is everybody excited so far? Okay, you look a little lost in the woods. Okay. We'll go over that again. No big deal. Okay, now, we're going from a magnetic azimuth this time to a grid azimuth. Okay, we're just flipping it back around. Alright, so number one, okay, or let me backtrack. Apply the mathematical formula to convert a magnetic azimuth to a grid azimuth. So number one, we're going to subtract an easterly GM angle from a grid azimuth to obtain a magnetic azimuth. This is to get the easterly GM angle. So in this example, if you look in your worksheet, you have a grid azimuth of 52.3 degrees. And to get the magnetic azimuth of an easterly GM angle, what are we going to do? We're going to subtract our GM angle. Okay? So we're given the magnetic azimuth, we're given a grid azimuth of 52.3 degrees. So what we're going to do is we're going to subtract the 2.3 degrees, right? We're going to subtract that from 52.3 degrees, and that will give us a magnetic azimuth of 50 degrees. Good job. Then finally, okay, now we're going to get a magnetic azimuth off a westerly GM angle. So you have a grid azimuth of 70 degrees. Okay? And this is a westerly GM angle. So what are we going to do here? We're going to add it, right? So we're just going to simply add a 2.3 degrees GM angle to our grid azimuth of 70 degrees to get a magnetic azimuth of 72.3 degrees. Okay, that is a great job. All right. So does anybody have any questions about how we're doing this? Okay. What I'm going to do now is we'll give each of you 5 minutes to practice these steps. Okay? And then we will go over that and evaluate. Okay, so starting now, you have 5 minutes to practice. Okay, 5 minutes are up. All right, in order to successfully get a go on this entire task, you have to receive a go on each performance step. If you get a no-go on any one of those steps or more, then we will go over your deficiencies and correct them. Okay? Okay, so this is task number 071-COM-1016, converting azimuths. Conditions: you are a member of a squad preparing to conduct tactical movement, and you have been directed to convert azimuths in preparation for the movement. You have been given a 1 to 50,000 military map with a declination diagram, pencil, paper, a magnetic azimuth, and a grid azimuth. And some iterations of this task will be performed in Mach 4. Standards: converting azimuth into a back azimuth, a magnetic azimuth to a grid azimuth, and a grid azimuth to a magnetic azimuth without error. All right, anybody have any questions? Okay. All right, we have 2 trained and 1 untrained. The retraining and retesting for this task will be at 1800 on 23 June, a couple of nights from now, tomorrow night, in building 203. The uniform will be OCPs with with a pencil, paper, ID card, and a water source. Alright, now, let's do our last and final PCC PCI. Okay, so everybody, make sure you have all of those items that you need. Okay, pencil, paper, ID card, and water source. Go ahead and get those out so I know you have them. Okay, does everybody have everything? Is anybody missing anything? Okay, good. Alright, moving right along. We are going to do an AAR. Some ground rules for the AAR. Everyone has a right to speak, and I want to encourage maximum participation. Please do not talk over each other, and always be respectful of differing viewpoints. Alright, so the first question of the AAR, what was supposed to happen? Well, I was supposed to introduce myself, and I was supposed to mention the task number and the task title verbatim. I was also supposed to discuss the overall risk level, hazards and controls, environmental considerations, and announce that we will be policing the training area once we have concluded the training session, and to go over security procedures. I was also supposed to do an initial PCC PCI to individually check everyone, make sure they have their equipment. I was also supposed to restate the task and the task number, and to read the conditions and standards verbatim. Also, I was supposed to demonstrate each example of the performance steps, going over the notes and warnings verbatim per step. And I was also supposed to ask if anybody had any questions for clarification on anything. Okay, I was also supposed to give 5 minutes practice. I was also supposed to do an evaluation. I was also supposed to give a retraining and retesting schedule for those who did not successfully complete this task. And I was also supposed to do a final PCC PCI. Okay, what did happen? What did happen? Okay, good. 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 Okay. What else happened? Great. Nobody has anything else? Well, good. What went right and what went wrong? Okay, good. Is that all? Great. Okay, how do I improve training for next time? What can we do to make this training better? Great. Awesome. Thank you. Okay, now I'm going to summarize the AAR. What was supposed to happen? I went over everything that I had planned in my outline to give this instruction. What did happen? Y'all responded back to me. What went right? What went wrong? And how do I improve training for next time? You gave me feedback on all 3 of those questions. That was very good feedback. Thank you so much. All right, were there any injuries or damaged equipment? Good? All right, great. Nobody got hurt, nobody got injured? Awesome. Are there any damaged equipment? Okay, so does everybody have all their equipment accounted for? Nothing damaged? Excellent. And were all the control measures implemented effectively? earlier in this block of instruction, we went over the hazards, identified those, and then just went over what to do to watch out for those. Awesome, great. Okay, now what I'm going to do at this time is I'm going to fill out the paperwork just to just get this paperwork done, saying that we had completed the training. No damages to the equipment. Nobody got injured. Nobody injured. All equipment is intact. No damages. And it is available for next training. Okay, now I'm going to do the hands-on evaluation, fill that out right quick. Again, we have 2 trained and 1 untrained. Again, the retraining will be at 1800, building 203, right here, Fort Jacksboro. Uniform will be OCTs. Please be sure to have a pencil, a sheet of paper, water source, an ID card. We will have the grid azimuth, magnetic azimuth, and a map. Does anybody have any further questions? Okay, before I dismiss you, let's make sure we police everything up. Let's make sure we pick up the training area. Make sure we put all the trash away in the trash bins. And make sure you have all of your individual equipment. Okay? So we tidied everything up. Everybody has all of their items. Okay, very good. Thank you all so much for your participation. You are dismissed. This concludes my training. I now request to close out the training site.